What have we got? Great.
The turning point, and we've got the X and Y intercepts and all that stuff.
Right, perfect, yeah. So we've got this turning point. So the turning point could be either a maximum or a minimum. And I know I went around and just explained that idea to a few of you. So the idea is that if you start up high, come down, reach the lowest point possible, then that is your minimum. And then opposite, start low, reach the highest point possible, and then come back down. That is when we have a maximum. And yeah, and then we've got a series of intercepts. So every quadratic function, every parabola when we graph it, has a y-intercept, but x-intercepts are different. Can we remember? What are the three options? Yeah, 0, 1 or 2. Can you quickly draw a sketch before I do about what that might look like? What would it look like if we had one x-intercept, 0 or none? Always a y? What did I say? I think I said 0 or none, didn't I? I meant 2. So 0 x-intercepts, 1 x-intercept, 2 x-intercepts. Yeah, just in that little section there. And there's one other thing that we haven't mentioned yet. What is it that we talked about yesterday? The line of symmetry. So the line of symmetry, usually we talk about the equation. So that's the line that splits that parabola in half. So you've got that direct mirror image. It always goes through the turning point. And it will have an equation based on the x value of the turning point. So I don't want you to get confused by that. We have done vertical lines as an example of linear functions, and they all have equation, what? X equals something. And so let's say with this parabola goes through x equals 3 as the part of the turning point, then the equation of that line would be x equals 3. So they are the most important features of the quadratic functions. The other thing I asked people to have a look at yesterday, for those of you that wanted that bit of a challenge, was the connection between the x-intercepts. Well, no, I just gave it away, didn't I? Sorry. Against the factorized form and the graph, which actually connects to the x-intercepts. So if we just quickly do one, and I'm actually going to pick, this one. The reason I'm picking that one is because it will be obvious. So that factors to what? X take, come on, how do I factorise that quadratic? X squared takes 6x plus 8. It's a trinomial. X take 4. X take 2, thank you. All right, so that factorises to x take 4, x take 2. Our x-intercepts are 4 and 2. 4 and, gosh, not having a good start to the day, am I? 2 here, 4 here. However, it's x take 4, x-intercept is plus 4. X take 2, x-intercept is plus 2. And so my third question was, well, why? Why is it, A, that we've got this connection, and B, the other thing is it's the opposite sign. What's going on there?
Is it because, like,
not really, no. No. Because we could do, you know, a similar thing over here, and this one factorises to x and x take 8, and that expansion has a take 8x there, right? But still our x-intercepts, one's at 0 and one's at positive 8. Anyone else? We're going to do this formally next week, actually, as a formal process. But I want you to start thinking about making those connections. There was a whole reason why we factorised all those trinomials a few weeks back. and it links directly to these quadratic functions. Really important. So linear functions are the ones we've been working with for up 10 years now. Now quadratic functions are the next big focus. They're the next type of function where this time it's an x squared term, that's the highest power of x in the function. And these are all quadratic functions. You should notice that's a dots. It's not a trinomial, there's not 3 terms there, but it can factorise in a similar way. And of course we've got this type as well. And I suggested to some of you that I walk past to actually take out the negative of this one first. And then factorise out the x. And you can see again, x-intercept is 0, and this one links directly to the 6. But it is the opposite sign, negative 6. So that's one we haven't seen where it's a plus 6, x-intercept is negative 6. So did anyone think about why that's happening? It's got everything to do with the fact that on the x-axis, what is your y value on the x-axis? The y value is always 0. Y is always 0 on the x-axis. So it's all about a connection between this function and solving that equal to 0. So if we solve something equal to 0, then let's say if that was just x plus 6 equals 0, what would x have to be? X would have to be negative 6. And that's why that x-intercept is negative 6, because we're solving that function equal to 0. Now, it's slightly more complex because we've got 2 numbers. You've got this and you've got that solving equal to 0. But when you think about this logically, and like I said, we'll do it formally next week, so I'm not going to spend much more time about this, but when you think about this logically, if you multiply 2 numbers to get 0, what can you tell me about at least one of those numbers? One of them has to be 0. So this one, potentially, the x plus 6 one, whatever that number is 0. Or x, this number has to be 0, which is just negative x is 0, which means x is 0. And that's where we get those 2 x-intercepts. So just highlighting that for you more formally, like I said, we'll look at that next week. So for those of you that did that challenge, that's the reason why that works in the way it does. Okay, let's keep going. With this first example, just to recap, I want to label all the key features. I want you to tell me what the equation of the line of symmetry is, what the x-intercepts are, what the y-intercept is, what the turning point is, and whether it's a max or a min. Did you get all that? Now, the hardest thing to do is probably just a reminder about that line of symmetry equation. Remember, the line goes through the x value of the turning point. Can someone give me the features for this one? Let's go. Who doesn't say too much? Sam, can you give me some features here from this graph? You got it in front of you?
Yeah, so, wait, what do you want me to say?
Anything.
The x-intercept is 3.
Good. So 3, 0 is the x-intercept.
The y is 0, 9.
Good.
The turning point is 3, 0.
And that's also the turning point. Perfect.
It's a min.
And it's a minimum. Excellent. All right, one more thing. Equation of that line of symmetry. X equals 3. Perfect. Thank you. All right, someone else for the next one. Let's go. Looking for someone. Nadia.
So the equation of the line,
Yep.
so x equals 3.
No, next one.
No, so, yeah, sorry. X equals -2.
Good.
It's like a maximum.
Yep.
That's all I've got so far.
Yep. So the turning point is a maximum. Cool. Can you tell me the coordinates of the turning point?
-2, 6.
Perfect. And now all we're missing are the intercepts. Someone else? Audrey, can you tell me those intercepts, please?
The y-intercept is 0, 2.
Good.
And the two x-intercepts are 0, 5, 0 and minus 4.5.
Excellent. All right, so that's all we're just practicing now. For the next two questions, I'm going to literally give you 1 minute each. Not even. You that were busy chatting at the back there, right? So when we give coordinates, we usually give them as a coordinate pair, but just make sure you put 0 in the right spot. So the x-intercepts start with the value, comma 0, because it's the x value and the y value is always 0 on the x-axis. The y-intercept starts with an x value of 0, y value of -4. The equation of the line of symmetry is always that x value, as I mentioned, of the turning point, which is x equals 0. And of course it is a minimum because it comes down, reaches a lowest point, and then comes back up again. All right, last one. Do we still need more time?
No.
Okay, let's do it. Jess, tell me.
I'm sorry if I'm wrong. So the coordinates are -1 and 4.5.
Yeah, -1, 4.5 for the turning point. Good.
And then the nature is max.
Good.
And then the x-intercepts are -4 and 2.
Yep.
And then the y-intercept is 0, 4.
Great.
And the equation of the line is x equals -1.
Perfect. All right, any questions about that? So, hopefully nothing too taxing about those ideas. It's just literally reading that info off the graph. So the way we extend these ideas is I give you the equation and you've got to tell me what those features are from the equation, which is a lot harder to do. However, I've got confidence in you. Before we do that though, we will be going the other way around. Start with the graph, give me the equation. Summary. I don't think I need to say too much more. You've got that in your notes. It's pretty straightforward. Okay, so at the moment, we are focusing on quadratic functions in turning point form. So as you probably are recognised, or maybe not, there are different forms in which we can write our quadratic functions. If we go back to these ones, see that x squared plus 10x or any of those ones that we had to factorise, they are not in turning point form. The advantage of turning point form is I can read the turning point straight from that equation. If I have a quadratic like this, we need to do a manipulation, an algebraic manipulation to get it to turning point form before I can work out what the turning point is. Or there's other methods as well, but that's one suggested. So this is kind of the general form. That's what we call general form. When it's factorised, that's factorised form. So each form has its advantage. The factorised form allows me to find the x-intercepts really quickly. The turning point form allows me to find the turning point really quickly. And the general form allows me to find the y-intercept very quickly. So each form has its advantage. We've got to eventually get through all of them over the next few lessons. But for now, we are going to stick with turning point form. So turning point form is really what we focused on when we did those transformations. Remember, a couple of lessons back, we looked at the idea of the translation left, right, up, down. We looked at how wide or narrow the parabola might be. So that is based on the three values in turning point form, A, P, and Q. So who can tell me the effect of A? What is it? Yep, tells us whether it's a min or max. So if A is negative, it's a maximum. If A is positive, it's a minimum. What else does A affect? Come on. Yeah, we just talked about that, whether it's inverted or not, which is ideally the max or whether it's a max or min. Not the gradient as such, but it's about the width, whether it's wide or narrow. So A affects that width. All right, what about P? What does P affect? That gives us the shift left or right, that translation, left or right. So remember, if it's, say, x take 2, that's going to translate to the right 2. All right, we talked about the opposite sign. And what does Q do?
Up or down.
Yeah, the shift up or down. So the easy ones are P and Q. Because as soon as we find a turning point on a graph, you can tell me straight away what P and Q are. A is a little bit trickier. We'll talk about how to find A in a minute. But let's have a look at these parabolas. Now, all of these have A either 1 or -1. In other words, the width is, they're all the same width. So they're all exactly the same size. That makes it easier. So all you need to do is tell me what the equations are based on where the turning point is placed, which connects to P and Q. If I take the blue parabola, now all of these are going to be written in turning point form. So they're all going to be this. My aim is to work out what A, P and Q are. It's a bit like, with our lines, we had to work out what M and C were. Gradient wind step. So here we're looking at A, whether it's narrow, wide, inverted or not. Now the width is the same, so we don't have to worry about a value for A, except that it could be 1 or -1. And then P is your shift left, right, that translation left, right. Q is your translation up, down. All right, so with this first one, the turning point is at 0, 3. So there is no horizontal translation. All that's happened with that blue parabola is that it's shifted up 3. Yeah. It's not inverted. So my A value must be 1. P must be 0 because there's no horizontal translation. It's just moved up 3. Y equals x squared plus 3. I think we've actually graphed that exact function previously.
Wait, where do you get 3?
So 3 relates to that shift up, right? It's the vertical translation.
So P is the turning point.
Because there's no P, because there is no horizontal translation. Yes, P and Q are the turning point of the parabola.
So they're the same.
So they're not necessarily the same value each, but they are the same x value. P is the x value of the turning point. Q is the y value. Yes. So see how I've highlighted green with green, and there's reasons why I highlight certain colours. Those colours do connect.
Wait,
Is that helpful?
Miss Conrad.
Yeah.
So would red be y equals brackets x minus 4 brackets squared?
Perfect.
Is that it?
Yep. So the difference with the red one is the turning point is 4, 0. So we have a horizontal translation, no vertical. So no Q, Q 0. So Q is 0, but this time P is 4. So notice we define turning point form as x take P. So then that P value is literally just the x value of your turning point. Right, so there's your horizontal translation, x take 4. We talked yesterday about why it's a take, not a plus. And obviously squared, otherwise it's not a parabola, it's not a quadratic function. And then this time Q is 0. So we don't write plus 0. That's, not viable. We never do that. But technically that's what it would be, plus 0. And because the parabola is upright and the fact that A is equal, we were told A is 1, it's the same width as all the others. And we can check that actually really quickly. The way we can check whether A is 1 or not is just to go, well, I can, if I increase my X value by 1, if my Y value increases by 1, it's not really a gradient. Don't want you to think it's gradient, but it's because our basic parabola, if we go all the way back to our very first parabola that we always drew, went back to x squared, all the way back, our very basic parabola of y equals x squared goes across 1 and up 1 from the turning point. That is one really quick way to check if A is 1. I just want to see that, just want to get to that table of values. Here it is. Eventually we'll get there. That one. Right, so see how from 0, x goes from 0 to 1, your y value goes up by 1. So that's just a really quick way from the turning point. It's always from the turning point. So in this one, there's your turning point. And over here, if we look at the next one, the turning point is here. So if I go across 1 and up 1, now remember this scale's different, then I know that it has an A value equal to 1. Anyway, that's just a little to the side to just check to see if A is 1. All right, let's look at the pink. What do we think?
Well, A is -1.
So the turning point, yeah, A is -1, good. So we know that's got to be negative. Turning point is 0, -2, which means it's only a vertical translation. It is not horizontal. Tells me that my P value is 0, but my Q value is I don't know why this happens to me. My Y value is -2, which means a vertical drop. And so Q's got to be -2. So this becomes -x squared, take 2. So inverted, shift down 2, translate down 2 is the correct vertical translation. And then the last one, which puts it all together, I guess, the aqua colour. This one, my turning point, so it's all connected to that turning point, hence the reason why this is called turning point form. All connected to the turning point. The turning point is what? -5, -5. So what's my equation? Y equals -x plus 5 squared, take 5. Perfect.
I think the question is kind of, does it have one? And when it says y equals take x squared, take 2, why does it take x squared? It's inverted.
You mean pink?
Yeah.
So negative, yeah. The negative is because it's inverted. That causes the parabola to go upside down. All right, and then the take 5. So notice here, just be careful because we should know if there's a translation to the left, X value is negative, but it's a +5. Oh, sorry, you can't see that on the screen. But it's a +5 in the bracket. It must be a +5. I'm actually just going to green on top of this blue. Doesn't help, but it is a +5 in that bracket. That's important. And think it's x take P squared, right? So it's x take P. That's the turning point form. So if P is -5, that's what that becomes -5. X take -5 is x plus 5. So that's how algebraically that connects. Any questions about that? So for now, I just want you practicing that. A is always 1 or -1. And the challenge will be, well, what if A isn't? What do we do? P and Q won't change.